on errors and exception handling topic. In the previous class, we covered file operations in Python programming and other initial topics like control structure and data structure. We all covered in the previous classes. The topic which we discussed today is errors and exception handling. So, errors and exception handling. First of all, I will give you brief introduction about what do you mean by an error, what do you mean by an exception, the types of error in general in any programming language, and the type of errors or exceptions in Python. As we know, when we execute a program at compile time or at run time, sometimes the output is not as per our expectation. So, generally the errors are divided into two types. One is compile time error, another is run time error. Compile time errors are those errors which found during the syntax checking of the program by the compiler. So, if you are having any syntax related problem, then in any high level programming language, that error can be handled at the time of writing of code itself. You can identify the error by compiling the program, and you can correct that error and execute the program. But some of the errors are semantic error or logical error, which does not have any syntax problem associated with the program, but they have some runtime errors, means while the program is in execution or the program is under running state, then that error arises, that is called as an runtime error or an exception. As you know, Python does not compile any code, it simply interpret and execute the code. So, we generally face runtime errors or exceptions in Python. I will give you one general example of a runtime error that is a very common error, that is divide by zero error. Divide by zero error. So, if I am writing any code and I am dividing it with the zero, during compile time there may not be any kind of error in that program. So, let us say if I have given three variable int a, b and c, a is equal to 10, b is equal to 0, c is equal to a divided by b. So, now this program does not have any syntax error. So, simply I have declared three variable int a, b, c. So, integer type abc variable are declared, a has been assigned value 10, b has been assigned value 0 and c is given value as a divided by b. So, when we compile the program on C compiler, C or C++ or Java, during compilation no error will occur because there is no syntax missing, semicolons are there, divide symbol is proper, assignment operator is proper. But when we run this program, when we execute this program, a runtime error may arise, that is called as divide by zero error. It is also called as an exception. So, you can also see it in the calculator itself. So, when you open the calculator in your mobile or a simple calculator, so when you divide 2 by 0, a error message appear divide by 0. So, when the system enters the divide by 0 scenario, the infinite loop starts its execution, because if we divide anything with 0, the output is infinity. So, infinite execution of a single loop may happen with bit by bit consumes the memory of our system, and at last the system got hanged or system got trashed. So, in that case, this kind of exception need to be handled by the exceptional handler mechanism. Otherwise, your system will enter into a resource starvation state or deadlock state, and you need to permanently power off the computer system, which may cause the loss of data in your system which is unsaved, or which may cause interrupted execution or interruption in the execution of a program. So, such kind of errors can be handled very wisely by different mechanism in all of the programming languages like C programming language, C++ programming language, Java or Python programming language. Every programming language has exception handling mechanism which handles different type of exceptions, so that your system does not enter in any infinite loop state. There are so many other examples of runtime errors. I have given just one example here, that is divide by zero error. So now coming to the Python scenario of handling the exception or runtime errors. So exception handling in Python, it is used to handle any unexpected error, unexpected, or you can say runtime error, which the programmer was not able to identify at the writing of the program or even by the compilation time if you are working in C or C++. Runtime error not only like divide by zero or manual error, maybe some buffer become empty or some unexpected arithmetic or logical or syntax error may arise at runtime. So in Python program, if any error arise at the execution of the program, then this exception handling mechanism is used to handle that program. Some common errors in Python are, I have divided into two categories. One is the common errors in Python, then we will see the detailed description of every error, what kind of runtime exceptions actually occur in Python. So the common errors in Python are name error, type error, index error, key error, or simply exception or runtime error. So now let's have a detailed description of different type of errors. The common errors may further classified into three categories, or you can say three types. Number one, file IO errors. File IO means input and output related errors when you are accessing any file within your main program. So file IO error means either there is a problem in opening a file, or there is a problem in closing a file, or there is a problem in writing or appending the content of a file or saving of a file. So these all kind of errors comes under the category file IO errors. The next is network errors or networking errors. When you are transferring data over a network, either internet or intranet, then such kind of errors which interrupts the transfer of data or bits through the network, these kind of errors are called as networking errors. There are some unexpected data errors as well. The one example I have given previously, divide by zero error, that is a data error because the data value assigned to a variable does not comply with the runtime execution of the program. That kind of error was called as unexpected data error. Or there is one further case, illegal argument error. So unexpected data errors are sometimes termed as illegal argument error. You have passed some wrong argument within a function. So like you have defined a function and you are passing a value within a function, then that is an illegal argument, does not specify the rules or the proper call by value or call by reference methods of passing an argument to a function. So broadly it is classified into these three categories. Some general questions which comes in our mind when we are doing exception handling or error handling in Python. What should happen when an error occurs in a program? So now it is a very common question, or the very first question which arises in our mind when we face any error in our program during its execution. What should happen when an error occurs in a program? There are two possibilities. Should the program quit, means divide by zero error like scenario, the system gets hanged, all the resources are utilized by the program and no available resource like memory or CPU is there to execute the program normally. In that case, either the program should quit or even the operating system should quit. Second case, should it recover from the error? Now this is the main important part. If any error comes at runtime, there is only one option to quit the program, or is there any option to recover from that error? So to recover from that error, we are doing exception handling. So if even at runtime any error occurs, then no need to worry. There are exception handling mechanism which you need to incorporate in your program that will handle the runtime errors and does not interrupt the execution of your program. So you need to focus on the second point. We need to recover from the error, not to quit the program. One more question arising related with the error or exception handling. How does a language allow a programmer to handle error? Now I am a programmer I have written the program of any particular problem statement, and I am trying to execute this program, and an error arised in that program. So how does a language like C language or C++ language or Java language gives you the functionality to handle the errors which are occurring at runtime? How you can handle these errors? Number one, any programming language allows the programmer or allows him to mark the block of code that can be potentially throws an error. So first of all, it allows the programmer to mark the block of code which is suspicious block of code. You can say there are some chances of error occurring at runtime. You may or may not, the error can come, but that is a suspicious code. When you are executing that code, there are chances of executing error or throwing an error in that case. So any language gives the programmer a functionality to mark the block of code. Means we have to write that block of code in the try block. Try, catch, finally, block, except. These are the exception handling mechanism which we'll discuss today. So it allows the programmer to mark the block of code that can potentially throw error. So you need to include that block in the suspicious code. If the error is thrown by that block, allow the programmer to handle it. Second functionality which any language provides to the programmer, that if that block which has been potentially marked, if it is throwing an error, then the programmer will be able to handle that block. That can be done by catch block or finally or except. So these are the some inbuilt functionalities: try, catch, finally, except, throw. You need to write the throw keyword if you want to throw the exception to a particular block of code which manually handles the error. So any programming language provides these two functionality. Number one, potentially mark the block of code that throws an error, and then to handle that error, it gives some another functionality to the programmer so that at runtime the programmer can handle those errors. Third case, but not always to be used, the language allows the programmer to raise an error as well. Language also has a functionality to the programmer who has written the program on which we are applying exception handling mechanism. It allows the programmer to raise an error as well. So that is the third option available in Python programming language, which allows a programmer to handle the errors, or you can say exceptions. So to handle the errors or exceptions, these three functionalities are available in our programming language. Now coming to the very important page or very important slide for today's topic, what kind of standard exceptions are available in Python? So one by one I will explain you all the standard exception. There may be more than these kind of exception available in Python, but the standard expectations are: number one, the name of the exception, column 1 is here, and the brief description is given here. Today we'll do the programming example of all these exceptions. So very first is exception name is simply an exception, which is the base class for all the exception. If you are facing any runtime error or any exception in your program, then you have to include this exception base class. Then the second one is your arithmetic error. I have given one example of divide by zero problem. There can be any other arithmetic error like signed or unsigned integers, or there may be some negative integer values. So then you need to include arithmetic error exception base class. It is a base class for all the errors that occurs for arithmetic calculation. So if you are doing some arithmetic calculation, then in that case, this is the base class. Arithmetic error is the base class for all the errors that occur for arithmetic calculation. Not only arithmetic kind of errors are there, I will discuss here all categories one by one. So third one is your floating point error. floating point means any floating point calculation fails, like 3 by 2, that is 1.5. That is a decimal value after 0.0. So in that case, if my data type is not appropriate, in that case a floating type calculation error may arise. So this floating point error is raised when a floating point calculation fails. Like I'll give you some real time examples of floating point error. Like you are calculating the interest on any saving bank account detail, you are calculating principal interest, you are calculating compound interest, and your calculation gets failed due to some missing argument or wrong argument passed in that case. Then floating point error may arise because our calculation failed, the actual floating point result does not come. In that case, a runtime error may arise. So there is a mechanism to handle all these kind of errors. So now fourth one is your zero division error. I have already explained you in very detail. It is called as divide by zero or zero division. Both names are appropriate for this. Zero division error or divide by zero error. It is raised when division or module by zero takes place for all numeric type. All numeric type means integer, float, and etc. numbers. So this is your divide by zero error. This kind of error arise when we divide a number by zero. Then IO error, I have also told you about the brief description of this error. IO errors are the errors which are raised when an input or output operation fails. Means you are inputting some data within a file, or you are outputting some data to the monitor screen or to the printer, or you are storing data in any file. In that case, if any input or output operation fails, then IO error can arise. So such as print statement, open statement, functions when trying to open a file that does not exist. Like I want to open a file abc.txt and that file does not exist in our system. In that case, there is no syntax error in the program because I have written the correct syntax to open a file, but the file is not available in the folder. Then at runtime, what system will do? System will raise an IO error exception handling mechanism, and an appropriate message will be printed on the screen or will be displayed in the printer output. Then next is your syntax error. Another kind of exception in Python we see are syntax error. These are raised when there is an error on Python syntax. The most common example is indentation. I am writing here, you need to remember indentation. So if you are not following the indentation mechanism, then that is a syntax error in Python. During writing the program, if you are not following indentation, because the Python does not compile the code, so when you execute the code, this may arise as a syntax error. So you need to follow the indentation rules of Python programming language. Again, it is again given here, indentation error is separately mentioned here. It is a one of kind of syntax error. Some other kind of syntax error may be like colon. So you have not written colon after the block function declaration. So colon, if the colon is missing, that is a syntax error. Indentation error raised when indentation is not specified properly. It also comes under the category of syntax error. Then the value error and runtime error. These two errors are the kind of exception which generally occur in Python. Value error means it is raised when built-in function for a data type has a valid type of argument, but the argument have invalid value specified. Like you have defined an integer variable and you are passing a character value inside it, or you have defined a floating point variable and passing an integer value inside it. So if you are passing wrong type of value within the built-in function or built-in data type of Python programming, then this value error may arise. The last one is your runtime error. The runtime error is raised when a generated error does not fall into any category. If an unexpected case arises, your error does not comes under your exception or arithmetic error, floating point error, zero division error, IO error, syntax error, indentation error, or value error, then that kind of unexpected error comes under runtime error. So it is raised when a generated error does not fall under any category, still the execution of the program is interrupted. That is called as a runtime error. Python provides the functionality to handle this error as well. So now, how to handle an exception in Python? Coming to the main practical part of today's topic, handling an exception in Python. First of all, exception is an event which occurs during the execution of program and disrupts the normal flow of the instruction, or you simply can say program. So as I already told you many times in this class, exception occurs during the execution of program, means at run time, and it interrupts the or disrupts the normal flow of program's instruction. A program is executing, the normal flow gets interrupted due to any kind of error which I have explained in the previous slide, then an exception may arise. So when a Python script or Python program raises an exception, either it must handle the exception immediately, otherwise it terminates and quits. So in the beginning slide, a question I have put up in front of you: what will the user do when an exception arises? Either the program quits or we handle the exception. So this is the both options available here. When a Python script or Python program raises an exception, alarms the programmer that an error is occurring or may occur in future, then either that exception may be handled immediately. If not handled immediately, in that case the program gets terminated. If the system or the program is not able to handle that exception, then it terminates and the program quits. This is the last case which generally not followed, because Python has a very strong exception handling mechanism. So it covers all of the kind of functionalities to handle the all kind of exceptions. So if you have some suspicious code that may raise an exception, means you think that there is some suspicious code which may cause exception or may raise an exception in future, you can defend your program by placing that code in a try block. So as I already told you in the previous slide, so if you think that there may get a chance of an runtime error or an exception, then initially while writing the program, you write that code in a try block. You have to write that code in a try block. After that, there will be except, else, finally. These are the options available to handle the exception handling in Python. After the try block, include an except statement followed by a block of code which handle the problem as elegantly as possible. So within the except block, you need to write the code which will be used to handle the exception raised by the try block. If try block does not raise any exception, then except block will not perform any function, because it does not require to handle the exception. But if the try block raise an exception, then the except block will handle that exception. Different ways of exception handling. Today we'll discuss all these three kind of Python's exception handling mechanism: try, except, else, try, except, and try finally. But before that, I'll tell you the syntax. This is the exception handling syntax. You need to remember how to write the exception handling syntax in Python. Number one, you must include the suspicious code in the try block. Statement to be inside try clause are like statement 1, statement 2, statement 3. You find that at runtime maybe arithmetic error may arise, or maybe file missing error, or file IO error may arise. So you have to write. Now here you can see colon option. After tries, a colon is written here. So you must include this colon, otherwise this exception handling code itself may have a syntax error. Then the except keyword. The except keyword first contain the name of the exception. Like I have told you, arithmetic exception, floating point exception, indentation exception. So you have to write the name of exception in except block. After that, what kind of statement to execute, you have to write with in as the keyword in case of exception happens. So the try block, if the try block raise an exception, then this except block accepts that exception with a particular exception name given here and perform some unique operation which are defined by the programmer to handle the exception raised from this block. If there is no exception in statements like statement 1, 2, 3, then there is no need to execute this exception code, except block. An empty except statement can catch any exception. So if I am not writing any name here, then it will catch all the exceptions. So that is a wide criteria, or you can say wide option. If you are not writing anything within the except, means any kind of error can be catched by this except block, and this except block will perform the required operation written inside this except block. There can be a case of finally close. Finally close can also be used here. I will show you with the help of example today. The finally close always executed before finishing try statement. So if the try statement is not finally finished, even then you can execute the statements written in the finally close. How to use that, I will show you with the help of example today. Okay, now coming to the three kind of exception handling mechanism. As one is try except else, the syntax is given here, the example is given here, the output is given here. Second is try except, third is try finally. So today we'll cover all these kind of exception handling mechanism. So now the programming part comes here. Number one, the case of exception handling in Python is try except and else. Now what do you mean by these kind of try except else? A single try statement can have multiple except statement. The syntax is given here. You can have a look on the syntax. First I'll give you the brief description of this try except else case, then we'll discuss its syntax, then we see a program on it. So try except else, a single try statement may have multiple except statement. Means a single try statement can handle multiple type of errors expected. A single try statement may contain IO error or arithmetic error or runtime error. So any number of except blocks or statements can be defined for a single try statement. It is useful when we have a try block that may throw different type of exception, because else case is given here. Except this, like if we are doing if else condition, so you are not sure what kind of exception may arise at runtime when executing this block of code, then this kind of first method try except else is very beneficial to handle more than one type of errors at runtime. This code in else block executes if the code in the try block does not raise an exception. If try has not executed or thrown any exception, the code written in except block will not execute. In that case, the else case will happen and the code written outside the exception handling mechanism will be executed. But if an exception is raised, in that case the code written in the else block will not be executed. The code written in the except block will be executed. Now let's have a look on the syntax of it. First of all, the try keyword or reserved word is written here. You have to perform your own operations here, like I have given example of divide by zero error, or you are inputting or outputting some file here. So within the try block, you have to write your own set of statements for which you want to do the exception handling at runtime. Now except block starts here. Say you are expecting any exception A. It can be a file IO error or input output error. So if there is an exception A, then execute this block. This is the first, because here we can see multiple blocks are there. Exception A, second is for exception B. There can be any number of except block. That is the advantage of try except and else block case. You have to write your code within the try block. If you are not sure exception A arise or exception B arise, or may exception does not arise, if no exception arise, then the else case will be executed. If there is no exception, then execute this block. Within these are the dotted lines. You can define any number of except blocks, and even if you are not sure no exception A occur or no exception B occur, in that case finally the code written in the else block will be executed. The most popular, most simple type of exception handling mechanism given in Python. So let's have a look on this program. This program will explain you the try, except and else case. You need to focus on the indentation given here. I have written this program. you need to focus on the indentation part. This part, a blank space has been given here before these all lines, because if you are not writing your try block and except or else block in the indentation format, then this block itself may create an error which is called as a runtime error or indentation error. So first I have written try block, then a colon is given here. Now I have created an object name fh. Fh is the object name which will store a file. The name of the file is test file. We have covered in detail the file handling operations in the previous video. So detailed description of file handling operation, you can also refer my previous video on this AKGC Digital School channel. So fh is equal to open test file w. You need to understand this statement very carefully. I have created an object fh. This will store the results of the open function. Here open function is defined. This open function has two arguments. One is test file, another is w. Test file means the name of the file which you want to open, and second is your access mode, in which mode you want to access the file. As I already told in the previous class, read, write and execute. There are three modes: read, write, execute. There are three modes of opening a file. In Python, one more mode is there, append mode. Generally there are three modes. Python provides the append functionality as well. So when you are opening a file, you have to write its mode, but it is optional. You may skip this mode option. Then by default the file will be opened in read mode. But here I have written w. W means write mode. I want to open the file whose name is test file, and in the write mode the contents of this file will be opened by the open function, and the temporary result will be stored in the fh object. Now once the file is open, I will execute one inbuilt method write. So fh.write, this is my test file. So if the file is successfully opened, there is no error in opening the file, or even the file is available not missing, and this fh.write statement executed successfully, then there is no runtime error or exception in our program. Simply this output will be printed. This is my test file, and it will be written in this test file. Because I am using the .write function, the test file will be written with this content. This is my test file. If test file does not exist, in that case itself a new blank file by the name test file will be created, and this will be stored in that file. But if there is an error in either opening the file in the write mode, means the file is locked with the permission of read only, in that case this line will create an error, because the file is locked with the read permission and I am trying to open the file with the write permission, or even the file does not exist and the creation of a blank file is not possible. In that case fh.write method will not be executed and a runtime error may arise. So that can be handled by this except block. IO error, here the error type I have given IO error. Except is the keyword, else is the keyword, try is the keyword, but except require a kind of error which you want to handle at runtime. So then if this is the case, the file is not opened properly, then this try block will raise an error or creates an error handling a call. Then this except block will be executed, which will handle only IO type error, because I have given the type of error to be handled by this except block as IO error. So IO error will be handled, and this print function will print the message as error, cannot find the file or read the data. This is a forward slash given here. You need to understand the concept of this forward slash. Means this single inverted commas special functionality has been disabled. It will not be printed here. Otherwise, if I had not written this forward slash, then this raised to power single inverted comma will be executed as a special operator. But to disable the functionality of a special operator, every language provides some feature. Here forward slash is given. In output, this forward slash will not be visible if the error handling mechanism is handled properly. The output message will be error cannot find file or read the data. But if no exception is raised by the try block and no IO error type of exception is handled by the except block, then else case code of block will be executed. Means there is no error raised, there is no error handled, then simple output will be printed. Return contents to the file successfully. I have written a print function within the else block, and this print function will display a message on the screen if this second line executed successfully. Return content to the file successfully, then I have closed that file. It is very important. When you are opening a file, you are writing the file, you are appending a file, or simply you are reading a file, you always have to close the file. Otherwise, the space or storage taken in the primary memory will be permanently consumed by this file. So you have to close the file properly. So fh.close function will close the file. In the else block, you need to take care. This code will be executed only when there is no exception raised by the try block and no exception handled by the except block. Here the output shown on the screen when I executed this program was return content to the file successfully. It means there was no error in these two statements, so except block is not executed, and the output displayed here is return content to the file successfully. And what contents are written to the file? That can be checked by this fh.write. This is my test file. So once again I will explain this program. It will tell you about the exception handling mechanism, category 1, try, except and else block. The code which you want to execute, and that code may be suspicious, you feel that there may error arise at runtime, then you have to write the code in the try block. The code written in the try block will be handled by the code written in the except block, and this except block, if successfully executed, then this else block will not be executed. If this except block is not executed, in that case this else block will be executed and the output will be displayed as return content to the file successfully. So this is first kind of error handling mechanism. Now coming to the second type, without else, only try and except category. After that we will go with the third type, which will be the try and finally case. I will give you a very brief description about this second type of error handling mechanism in Python. So it catches all exceptions that occur. Any kind of exception, if it is arising, it will catch and it will handle that. It is not considered as good programming practice. You have to use try, except or else block as a error handling mechanism. If you are not using the else case and an unexpected or a new type of error may arise, then in that case there will be no option to handle that else case. So it is not considered as a good programming practice, though it catches all exception, and it help the programmer in identifying the root cause of the problem that may occur. It is generally able to handle all kind of exception being raised by the code written in the try block, but still you are not aware that what kind of exception is arising or what kind of exception handling mechanism the programmer need to take care in advance. Means by way it is helping the programmer to handle all kind of exception. As like goto statement, I will give you one more example of this one. We generally do not use goto statement in C programming language. Still goto is available to jump to any line of code in the program, but a good programmer does not use goto statement within its program because it gives the functionality or help to the programmer to jump to any code of block within the main program. Same case here, except can handle all kind of exception, but the programmer will not be aware about what kind of exception, IO error, arithmetic error, indentation error or syntax error is arising. So programmer simply catch the exception and display a common message or common exception handling mechanism. That is why it is not in good practice. Let's have a look on the syntax of this one. First of all, I have to write our code on which I may think that there may be an exception. So you do your operations here. You write your suspicious code which may raise an exception or error at runtime within this try block. Then the except block, like maybe an exception A is an IO error. Then if there is an exception A, then execute this block. If there is an exception B, then execute this block, and goes on. But there is no else case given here. So this is the difference from the main try except else kind of exception handling mechanism and simple try and except exception handling mechanism. Now let's have a look on the example of it. I have taken the same example which I have taken in try, except and else case. You need to again focus. I have given the indentation here. So you need to take care of the indentation. There is no else case written here. So first of all, try keyword, then a colon is given here. I have created an object fh. I have executed the function open. I want to open a file that is test file. If this file exists in the system, then the file can be opened. If this file does not exist or it is not available to open in the write mode, as W means you need to open the file in the write mode. If there is an error in executing this statement, then this IO error can be handled by this way. But before that, if the file is successfully opened, there is no error, then the content written here will be written in the file. .write function is used to write the content in the file. This is my test file for exception handling. So I have written a simple message which will be written in this test file. The message is, this is my test file for exception handling. So this exception handling will be, this complete write method will be written in this test file because the file is opened in the write mode. If there is an error in opening the file in the write mode, or if there is error in locating the file, then this except block will handle this IO type error. You have to print the message within this except block that error cannot find file case 1 or write data case 2. Any one of the case may be you are not able to locate the file or you are not able to write within the file because the file is locked with the read permission. Then this is the output of this program. The output shows here cannot find the file or write the data. So in that case, you will not be able to handle any kind of error if there is no error is arising by this try block. So this is the try except case, but if except block is not executed, means the operation done in these two lines are successful, then no output will be displayed, because here the print is given only in the except block, and you can see here / is not shown here because it is a special symbol to deactivate the functionality of this single inverted comma. Only the message error cannot find file or read data, write data is given here, but only in the case if this except block handles the exception raised by the try block. Otherwise, no output will be displayed. If you want to print any output, then you have to write the print function here. This was the second case of handling errors or exceptions in Python. Now coming to the last case, try and finally. This is the third way to handle the exception or errors in Python programming language. Finally block is a place to put any code that must execute irrespective of try block raise an exception or not. So this finally block will always execute even if the try block has not raised any exception. Then in that case the finally block gives some another output. If the except block is even skipped, no except block is written here. To handle the exception, this finally will do all the operation. Else block can be used with finally. This is the third case, or you can say we can use else case as well. As like try finally else, there was the case of try except else, but it is not necessary to use the else case. First I will tell you the syntax of this try and finally, then we'll do its programming example. First of all, you need to write the try keyword, reserve word, with a colon. If you are not typing colon, then it will generate an error. Then your source code will be written in this try block. This source code will be the suspicious code in which you feel that there may arise an error at runtime. It can be a divide by zero error, IO error, or our example like file opening error. Due to an exception, this may be skipped. Now, finally block. This would always be executed. You have whether the try block is executed or not executed. The finally block will be executed as always, and you can also include else case after that. So let's have a look on its example. This is the same kind of example with indentation given here. I am using the same example in third category. First one was try except else, second was try except, third is try finally. So I am opening a file with the name test file in the write mode. W means write. If you want to open in the read mode, then you have to write R. If you want to open in the append mode, then you have to give the access mode as append A. So the file will be opened by this open function and the object will be created with the name fh. Now you want to write this string within that file. This is my test file for exception handling. You want to write this string by the help of .write method. The file is opened and the object is created as fh. Now on this fh you are performing the write operation, and the content to be written within that file is, this is my test file for exception handling. If there is no error, no problem is occurring, even then finally block will be executed and will get the output as cannot find file or write data. So if you are writing any message within the finally block, it will always be printed. Here I have assumed that the file is not available or the file is not able to open in the write mode. So if the file is not able, then the case 1 cannot find the file, or the file is fine, test file is available in the same directory or folder where the source code is written, but we are not able to write the data, means the file is opened in either read mode. Then the second case arises. So this finally block will display the output always, even when this code is successfully executed. There is no problem in writing the code in this file, still finally will display. It is also used very less. The most popular way of handling the exception handling in Python is try, except and else. So these are the three kind of exception handling mechanism. So I am summarizing today's topics. Today we have done the error and exception handling mechanism in Python. First we identified what do you mean by an error, what do you mean by a runtime error or compile time error, or how high level programming languages handle the errors at compile time or runtime. Then we discuss about different type of errors like arithmetic error, logical error, semantic error, syntax error, indentation error, IO error, or some general errors or exceptions. Then the different categories of errors can be handled in different ways. So the different methods to handle all those errors were, there are basically three kind of methods. One was try, except and else. Second was try except, and last one was try finally. The most popular method is try except else. So we have covered three kind of exception handling methods in Python with their programs, with their example, with their syntax, with their explanation. Now today's your home task is to execute these programs on a interpreter. You can use any online interpreter like pythontutor.com, or you can install Python in your own system, or you can use Google Collaboratory Research Tool. Google is providing the research tool for executing Python program. So you can use any one of the three kind of methods to execute this program. If you want to see step-by-step visualization, then pythontutor.com is the best website to step-by-step visualize the output of these codes and to check whether an error is happening or not. So this is all about errors and exception handling in Python programming language. In next class, we'll start with the next topic. If you have any doubt, even you can write your comments in the video after this live demonstration. I will check the comment and reply on the videos. Thank you very much. Have a good day.